Assalamualaikum, my name is Nuris Alia binti Zainuddin and today I will be presenting multi-agent application. Atlas Robot is the most dynamic humanoid robot that was built in 2016 in United States. It is a research platform designed to push the limits of whole body mobility with 28 hydraulic actuators, 6 for each leg and arm, 3 for the back joints and 1 for neck pitch. The dynamic speed is 2.5 meter per second with 1.5 meter of height and 89 kilograms. The slide shows 8 activities need to be solved by the Atlas, since it can lift and carry objects like boxes and crates, and its favorite tricks are running, jumping, and doing backflips, so on and so forth. Hence, in the 2015 DARPA competition of robotics, Atlas was able to complete all 8 tasks. So, Smith et al. In 2014 illustrated the architecture. From remote components, both a 3D environment based on the LiDAR data and the robot's camera feed are displayed to the user. Next is the off-board field component, focusing on controller and state estimator. State estimator takes data from the robot's joint angles, velocities, inertial measurement unit, IMU orientation, rotational velocity, and linear acceleration to read joint angles, velocities, and location in predetermined world coordinate system. Additionally, the state estimator is in charge of filtering incoming robot signal data, while controller is the application of the working algorithm and full body control. Calculates the desirable joint forces required for the robot to walk with a steady gait, even when doing complex activities like manipulating things that may cause reaction forces that need to be taken into account, such as turning a tight valve or carrying a tube. The user interface sends desired tasks, which are then asynchronously received and used to organize the subsequent motions. Lastly, using a high bandwidth to communicate and low latency fiber optic network to connect the Atlas robot's onboard computer. Decision making in perception for parkour. The Atlas team at Boston Dynamics uses parkour as the ideal sandbox to test out novel behaviors. Humanoid robots show off their whole body athleticism by staying balanced while engaging in a range of quickly shifting, high intensity exercises. 2 pictures illustrate how Atlas being pushed to its boundaries to find the newest in mobility, perception, and athletic intelligence through jumps, balance beams, and vaults. The process as shown. Robot perception algorithms are used to transform data from cameras and LiDAR into information that may be used for making decisions and organizing physical activities. Atlas controls its body movements and feels the ground for balance using IMUs, joint locations, and force sensor. It needs perceptions to recognize and avoid obstacles like the gap and narrow beam. Atlas uses real-time perception, which are depth sensors, to generate point clouds of the environment and detect its surroundings. Next, producing point clouds of the surrounding area at a rate of 15 frames per second using time-of-flight depth camera. The point cloud is a massive array of distance readings, following by surfaces that are extracted from this point cloud by Atlas perception program using a multi-plane segmentation approach. The results of this algorithm are sent into a next process, which is a mapping system. Mapping system creates models of the various objects that Atlas camera captures. The recognized rectangular faces of parkour obstacles are marked with orange outlines and are tracked over time through sensor data. Before it reaches an end, specific behaviors are planned using these recognized faces. The green footsteps, for instance, show a future strategy for where to jump and run after each step. The robot has whole body dynamic balance and is made to work both outside and inside of the environment. With that, it marks the end of my presentation. Thank you for listening.